So we're trying to show 1 plus I tangent theta to the power of n plus 1 minus I tangent to the power of theta. Tangent theta to the power of n equals cos n theta divided by cos theta all to the power of n. Yeah. So for this question here, all we need to do is, because you see the power again, so you see here is to the power of n, we would consider to use polar form. Okay, we would consider to use polar form. Yeah. So we have 1 plus I tangent theta. Okay, we'll just consider that and then convert this into polar form. Yeah, so let's just try to do the conversion. Yeah. So we said if you have a plus bi, and then you want to convert it into r cis theta. Okay, so r will just equals to square root of a squared plus b squared. Theta equals to tangent inverse imaginary over real. Okay, yeah. So we just follow the same thing. So the modulus would be square root of 1 squared plus tangent squared. Yeah. So 1 plus tangent squared is sec squared, right? 1 plus tangent squared is sec squared. So equals to square root of sec squared. Yeah. So sec squared over square root, that just equals to sec theta. Okay, so that's your modulus. And then your argument, theta equals to tangent inverse b over a. So b is tangent theta. A is 1. Yeah, so that just tangent inverse tangent theta. So you have a function, you have the inverse function, so we go back to identity, which is just theta itself. Okay, so this just equals to theta. So 1 plus I tangent theta. When you properly convert this into polar form, that just becomes sec theta multiplied by cis theta. Okay. Sec theta multiplied by cis theta. And then when we have 1 minus I tangent theta. Okay, so you can see 1 plus I tangent theta and 1 minus I tangent theta. They are conjugate of each other. Okay, they are conjugate. Yeah, so if two complex numbers are conjugate of each other in their polar form, one would be r cis theta, one would just be r cis minus theta. Right? You don't really need to do anything. You just copy the same thing down, replace that theta by minus cis and by minus theta. So just have sec theta multiplied by cis minus theta. Okay. Okay. Yeah, so that just is entire thing, and then we can simplify this equation. So let's start with left hand side. So left hand side equals to sec theta cis theta all to the power of n plus 1 minus sec theta, and then cis minus theta all to the power of n. And then sec theta to the power of n and sec theta to the power of n, you bring them together. Just 1 on cos, right? So we have 1 on cos to the power of n. Okay. And then this cis theta to the power of n, you can change that cis theta to the power of n become cis n theta plus cis minus n theta. Yeah, so cis n theta plus cis minus n theta. Yeah. Cis n theta, that's cos n theta plus I sine n theta. Yeah. Cis theta minus n theta will just be plus cos minus n theta plus I sine minus n theta. Yeah. However, cos is an even function, so cos minus n theta is still cos n theta. Sine is an odd function, yeah, so minus n theta become a minus I sine. So those two cancelled. So overall, those two cos just become 2 cos n theta divided by cos to the power of n. Okay. Yeah, so this should be 2 cos n theta divided by cos to the power of n theta. That's one way to do it. Okay. And then let's have a look at method 2. Okay. So instead of converting everything into polar form, I just want to convert tangent theta. Yeah, so in trigonometry, we said whenever it's a tangent, we convert that into sine over cos. Okay. So if tangent is sine over cos, one would be cos over cos, because we want to make sure they both have the same denominator. So method 2 will just have cos theta over cos theta plus I sine theta over cos theta all to the power of n, and then plus cos theta over cos theta minus I sine theta cos theta all to the power of n. Okay. Yeah. So you can see we have cos theta to the power of n, cos theta to the power of n, cos theta to the power of n, cos theta to the power of n. They all just cos to theta to the power of n. You can take that out. It would be 1 on cos theta all to the power of n. Yeah, and then cis theta to the power of n, right? That just cis theta to the power of n plus cis minus theta to the power of n. Okay. And then first of all, you can bring n in, right? Using the De Moivre's theorem, so we have cis n theta plus cis minus n theta. Yeah, and then do the cancellation the same as before. So overall, we just get 2 cos n theta over cos to the power of n theta. Okay, yeah. So that's the second method to do the same question. Okay. And then they ask you to show I to the power of tangent 3 pi over 8 is the solution of the equation 1 plus z to the power 4 plus 1 minus z to the power 4 equals 0. Yeah, we just need to expand this. Okay. Yeah. So let's give it a go first. So we just need to show 1 plus z to the power 4 plus 1 minus z to the power 4 equals to 0. And then one of the root is I tangent 3 pi over 8. Yeah, so you simply just plug this root into the equation and then trying to show left hand side equals to right hand side. Yeah. So when we plug it in, the left hand side equals to 1 plus I tangent 3 pi over 8 all to the power 4 plus 1 minus I tangent 3 pi over 8 all to the power 4. Okay. So you can see it's 1 plus I theta to the power of n plus 1 minus I tangent theta to the power of n. We can bring this together using the formula we just proved. Okay, here 1 plus I theta to the power of n plus 1 minus I theta to the power of n equals to 2 cos n theta divided by cos to the power of n theta. In that case, n just equals to 4. Okay, so it would be 2 cos 4 theta cos to the power of 4 theta. Okay, so from part 1. Yeah, so from part 1, this entire thing, this will just be the cases where n equals to 4. So we have 2 cos 4 multiplied by 3 pi over 8 divided by cos to the power of 4 3 pi over 8. Okay, and then you don't need to worry about the bottom thing. Okay, just have a look at the top part. 4 multiplied by 3 pi over 8. This is cos 3 pi over 2. Yeah, so cos 3 pi over 2 equals 0. This entire thing just equals to 0. Okay, the numerator equals 0, the entire thing equals 0. So the left hand side equals to right hand side. Okay, therefore it is a root. Okay, therefore it is a root. Okay, and then they told you one solution is this, and then they ask you another solution. If you just look at this, we have 1 plus z to the power 4. Sorry, 1 plus z all to the power 4 plus 1 minus z all to the power 4 equals 0. Yeah, you can see they're all real, so real to the power of 4 still real numbers. So all coefficients are real, and the conjugates must be another solution. But in the exams, we're just trying to show it slowly. Okay, you need to properly prove all the coefficient is actually real just by using the binomial expansion. Yeah, so just have a look at the coefficient first using Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. Okay, so when it's plus, everything is plus. So the first part is fine. When it's minus, remember the signs need to alternate. So you start with plus, minus, and then plus. Okay, that's when you're doing 1 minus that all to the power 4. Yeah, so let's just expand them part by part. 1 plus z to the power 4 would just be 1 plus 4z plus 6z squared plus 4z to the power of 3 plus z to the power of 4. Okay, plus 1 minus that to the power 4, you just need to clearly follow the rules. Plus, minus, you need to follow the signs. So this one would be 1 minus 4z plus 6z squared minus 4z cubed plus z to the power 4. Okay, and then this entire thing equals 0. So you can see this and this, they all cancelled. Although they're all doubled, but there's a 0, so you divide everything by 2. It will still be z to the power 4 plus 6z squared plus 1 equals to 0. Okay, so now you can conclude, because all coefficients are real, because we clearly showed those are all real numbers, so you have conjugate roots. The conjugate roots will just be minus I tangent 3 pi over 8. Okay, so this is the end of the question.